In this video, we'll write the net ionic equation for HNO3 plus CaCO3. This is nitric acid and this is calcium carbonate. So the first thing that we need to do is balance the molecular equation. So this is the molecular equation here, and to balance it, I think all we need to do is put a coefficient of 2 in front of the nitric acid. So we have a balanced molecular equation. Now we need to write the states for each substance. So HNO3, that's nitric acid. It's a strong acid, so it's going to be dissolved in water, dissociated completely into its ions. For the calcium carbonate, let's take a look at that on a solubility table and see what we can learn about whether it'll dissolve or not in water. So here's calcium, and then carbonate's here. So if you go down and look, you can see there's an I. That means it's insoluble. It's not going to dissolve in water, so it's just going to sit there. It's going to be a solid. To be clear, a little bit of it will dissolve, but for the most part, it's going to be a solid, so we write solid in our net ionic equation. Water is a liquid, carbon dioxide, that's a gas, and then nitrates are very soluble, so that's going to dissolve too. That's going to be aqueous. Okay, so we have our states. Now we can split the strong electrolytes into their ions, and that'll give us the complete ionic equation. So the strong electrolytes, those are the ones that'll dissolve and dissociate completely, like the nitric acid here with the aqueous. So before we do that, we do need to write the charge for each one of these ions here. So let's see, hydrogen group 1 on the periodic table, that'll have a 1 plus charge. And then the nitrate, that's a polyatomic ion. You really should remember that NO3, it's going to be NO3 minus. So we have 2H plus, and I'll write aqueous at the end. I won't write that now. Plus, we have 2 of those nitrate ions, 2 NO3 minus. For the calcium carbonate, it's a solid, so it's not broken apart. It's actually together. It's an ionic compound all together, so we can't break that apart. So we'll just write CaCO3. In net ionic equations, we don't break solids, liquids, or gases up into their ions. So we have our reactants, and then our products, we said we didn't split liquids up, so it's just H2O, plus a gas, CO2. We don't split those up either. But then we said calcium was 2 plus, the nitrate ion 1 minus. So we'll have our Ca2 plus, because this is a strong electrolyte. It's aqueous, it'll break into its ions, plus that NO3 minus, that nitrate ion. But be careful because this little 2 here, this subscript, that means we have 2 nitrate ions, so we put a coefficient of 2 to show that. So this is the complete ionic equation. Sometimes it's called the total ionic equation. Now we can cross out spectator ions. These ions appear on both sides of our complete ionic equation. In effect, they haven't changed, so we're not interested in them. I can see I have 2 nitrate ions here in the reactants. Then in the products, I have 2 as well. I can just cross those out. They haven't changed. Everything else, though, is unique. So this gives us our net ionic equation. We have our 2 hydrogen ions, our solid calcium carbonate, water, carbon dioxide, this calcium ion. That's the net ionic equation. Let me clean this up. I'll put the states in, and then we'll have it written nicely. And this is the net ionic equation for HNO3 plus CaCO3, nitric acid and calcium carbonate. And this is Dr. B. Thanks for watching.